I wish you a wonderful day and welcome to the OXL YouTube channel. In this video, we will talk about the basics of managing a NFTables Ruleset. This will be interesting, so let's get started. Of course, we are back on our demo environment. Today we have 3 terminals open. On the left side, we will configure our ruleset. On the right side top, we have a real-time view of our log file, and on the bottom we will create connections to test our rules. Of course, our default rule set, as we've seen in the last videos, is pretty slim for now. The first step we'll take in managing the rule set is to restrict traffic in the input chain. Input traffic, the traffic handled by the input hook, is traffic that comes from the network to our firewall. So, what rule will be the first one we need to add? Of course, the rule for our own management access. We currently use SSH to manage the configuration of this firewall, so we will need to allow SSH to the firewall before dropping any traffic. If we don't explicitly allow management access to the box, to the firewall, we will lock ourselves out. So, how will we allow it? First, we'll check the IP address, the subnet of the firewall. As this is a demo environment, we'll just allow SSH access from that local subnet. Of course, if you are on a production system, you will use a dedicated management network and only allow management access from that specific management network. And of course, strictly restrict the access to the management network itself. So, we add a rule for the TCP destination port 22 from the local subnet and accept the traffic. To make sure this rule works as expected before we deny other traffic, we will add a log prefix to it, so every packet that is matched by this rule will be logged, so we can be sure it works. Now we reload the config to activate it, and we immediately see many logs. These are around 10 lines of logs per second, so for a single connection, pretty many logs. Next, I'll show you how we can handle TCP logging to only log the first packet in a TCP connection. This can be handy if we have rules that allow management access and we want to lock the management access, but we don't want to overwhelm our log system with logs that nobody needs. So we can just duplicate this rule. The first one will be the line that logs the new sessions, so we can do that with CT connection tracking state new, and the same rule as before, and the bottom rule will not log the traffic. So every other packet except new sessions will be handled by the second rule and thus not be logged. So if we reload the config, it gets activated. We can now restart our log live view. Yeah, we see no logs are there. If we start a new connection, we get exactly 1 log. I would always recommend the usage of a central log system. This can have many benefits, but with this example of logging management access, we can centrally create a visualization of those management connections and get a quick overview over which IP connected to which target system at what time, and also define alerts whenever management access connections get established at weird times when nobody's in the office or something like that. That could hint towards an attacker probing our network. Of course, using a central log system has also the benefit that the logs of our source systems, in this case our firewall, also are archived on a separate system. Because if somehow an attacker gets into our system, in this case the firewall, they can modify and delete the logs. But if they are already sent somewhere else, archived somewhere else, we can at least do a post-mortem analysis of what happened. Now let's hop back into our configuration. As we see, we have our two rules here, and we also see we have some duplicate configuration here. We have the subnets duplicated and also the port. What can we do about it? We can create variables that replace and deduplicate that configuration. We can define a variable using the define statement, set a variable name, in this case net_management, and assign a value to the variable. Then, inside the rules, we can reference the variable using the dollar and variable name. This can also help us to get a little better overview over our configuration, especially whenever the configuration grows. If you have 50 to a few hundred rules in there, it's really useful to have those settings deduplicated. We also have added a port variable for the management access here, just to showcase that we can also use multiple values inside one variable. We have added the 443 port to that one. The configuration is valid, and if we reload the configuration, the SSH access still works. So, looks good. Variables can also be used for more advanced features like named limits, meters, maps, and so on, but we will cover those features later on in later videos. Most of the time we will use variables to contain networks, IPs, and of course ports. We will now just quickly cover how to use a dedicated configuration file for variables. This can be handy if you want to auto-generate a configuration file containing variables, if you have some scripts running or an automation solution like Ansible, or want to allow certain users to manage a single configuration file. Yeah. You see we have the _vars_conf here. That __ prefix is used as the configuration files are included in order, because the variable of course needs to be defined whenever we reference it, else we get a syntax error. In this case we have a simple array set of IPs that target a DNS server. To showcase that this variable actually works, we will add a rule to our configuration. In this case we will add an outbound rule for DNS traffic. Of course we still have the default policy accept here, so it really doesn't make a difference for now, but just to showcase that the variable works. We reload, so the configuration is valid, and if we check out our running config, it looks good. The variables are resolved and it works. Next, we will look at the connection tracking. We have already used the connection tracking to conditionally log new management access connections. Now we will also use the connection tracking state to allow response packets. Let me explain with an example. We now have allowed SSH access on the input chain. So inbound SSH access is allowed. If we now set our output chain to default policy drop, we will still not be able to create a new SSH session, even if the inbound traffic is allowed, because the outbound response packet will be dropped. We can handle this using the connection tracking state established and related. The connection tracking state here refers to the TCP connection state. In this case, with this rule, the connection will still be possible, the inbound connection will still be possible, even if we set the output chain to default policy drop. We will also add this established related rule to the input chain, because we will need it whenever we create new outbound connections, like downloading an update. Then the response packets will come to the firewall on the input. We could also further limit that established related accept rule to require the destination port range 49,000 upwards, so the dynamic port range, as response packets usually use those destination ports. As we have the established and related connections allowed, we could also remove the second management access rule, as those packets should be handled by the connection tracking state rule down below, but as it's anti-lockout rule, I personally would keep the second one in there just in case. As mentioned before, the connection tracking state relates to the TCP connection state, but we also have the ability to load additional kernel modules with the prefix nf_contract_ to enable connection tracking for some applications that use UDP traffic, like FTP or SIP or SNMP. If you need such functionality, you can look into it. Of course, if we use the forwarding chain, the forward traffic, as this might be a network firewall later on, we also have to allow established and related connections there. As we have seen, the dropped packets were not locked. How can we change that? How can we log packets that are dropped by the default policy? It's pretty simple. We can just add a log prefix statement to the end of the chain, as every packet that hits the end of the chain gets the default policy applied. So we'll just add a generic log prefix here, NFC drop default input, so we can find out where those packets were dropped. And if we now get a drop, we see the logs. If your firewall or server is connected to the public internet, you might also want to limit the maximum amount of log lines that are written per second. Let me give you a practical example of how this can have a negative impact, if not limited. I have seen an attacker use a botnet to aggressively port scan a target system. This resulted in hundreds of thousands of logs per second, and thus had a negative impact on the disk I/O. It basically resulted in a denial of service, so it was a distributed denial of service attack. This can be avoided by simply adding an anonymous rate limit to the log prefix. With 1,000 logs per second, you should be good to go. You can also use less, however you want. And at last, we will add some rules to allow traffic from and to the loopback interface, so we can contact our local host, of course. Yeah, in the input chain we allow the input interface loopback, and in the output chain the output interface loopback. If we don't allow this traffic, we might get some pretty random issues, as the system depends on it. Yeah, okay. This is pretty much it. I hope you enjoyed the video. If you're interested in learning more about NFTables, keep watching our playlist, subscribe, like, and in the next video we will talk about rule matching. Okay, for now, have a nice day and servus.